All right, guys, I tried to do the best I could with these notes. Obviously, I couldn't get into the school, so it is what it is. So I had to do these at home. I'm trying to make this little makeshift video. We're dealing with growth and decay as well as half-life. Um, and there's just three different formulas and understanding where each one gets plugged in. I went ahead and did the first four just to kind of so that my hand was out of the way and I could kind of pinpoint things out on this. So when we're dealing with growth, here's our formula. Decay, here's our formula. Half-life. If you think of it this way, what half-life means is that it's based on decay and how long something will take until half of it is gone. So for instance, if you had $500 and it had a half-life of a month, after 1 month, you'd have $250. After the second month, you'd have $125, and so on. So it cuts whatever that is in half through each half-life. Hope that made sense. But our A is our final amount on all of these. So it's basically, if it gives you the final amount, then you got to work backwards. But usually we're going to give you the P, or the initial amount. T is for time. Time could be in years. It could be in days. It could be in months. The half-life, or the H, will be given. In other words, like I just said, if it was a half-life of, normally it wouldn't say a month. It would be very specific, like 30 days or 10 days or whatever. So it'll be telling you what the half-life is, as well as your R is your percentage or your rate, and you have to move that decimal over because you have to put it in decimal form, and it's not as opposed to in percentage form. So we read the first one. Ellie wants to attend State University where the annual cost of tuition is $4,300 in 2020. Each year the tuition has risen 4%. That means it's going to be dealing with growth. Find the cost of Ellie's tuition in 2020. So in 2000, it was $4,300. In 2020, which means our time's going to be 20 years. The initial amount is $4,300, and our rate is 0.04, or 4%. We plug into a formula, we plug into a calculator, and we're going to find out that in 2020, tuition would be $9,421.83. Obviously, significant growth. 4% is a pretty big hike of a percentage over that short period of time. But you'll see the difference is what we're dealing with. You just plug it into the calculator and you go. There's no way to figure that out. I mean, there is a way, but I wouldn't do it. Next one's depreciate. We're dealing with a car. Obviously, we should understand if you buy a car, it's going to depreciate in value, at least initially. Depends on the car. Obviously, some cars get more expensive with time, but most of the ones we're dealing with is going to be depreciation. Initial price of the car is $34,000. Depreciates, which means negative 13% each year. Find the value after 3 years. So when we plug in 1 minus 0.13, that's like saying $1 minus 13 cents. So it's 87 cents, if you will, or 0.87 percentage of a whole. And put it into the formula, plug into the calculator, and you find out that after 3 years, your car is only worth $22,389.10. Again, dealing with money, so we're going to the cents. Hopefully you understand that. We're rounding in the tradition of American money. We're dealing with pennies. So we go to the tenths, or the cents portion of it, the hundredths position. And that's how that one will be done. The next one's dealing with half-life. The half-life of iodine 131, which means nothing. That's just what you're dealing with. You don't have to deal with 131. That's just a product, if you will. Is about 8 days. So my half-life, or my H, is 8 days. For an initial sample, so my P is the initial amount of 50 grams, What is the amount of iodine 131 remaining after 12 days? So my time is 12. So I'll plug in my 50, my initial, to the half is just basically, that's the half-life formula. My time is 12 days, but my half-life is 8. So if you think about it in these terms, after 8 days, half of it, he's going to have 25 grams. It's after 8 days, it's a half-life. So he has 25 grams. So it's obviously going to be lower than that. It's another almost half of the next half-life, if you will, going through 12 days. Find out that it is 17.68, and we're dealing with grams because we're dealing with our initial amount is grams. Up here we were dealing with money. Now we're dealing with grams. And I rounded to the hundredths place as well, just to be consistent. This one's a little bit different. John has inherited the land from his grandparents that was purchased in 1970. The value has increased by approximately 2% per year. The land is now worth $120,000. What was the original amount? Here we don't know the initial. We know the final. The final says at now it's worth $120,000. We don't know what the original amount was. We know that the time is 50 years. Hopefully we know from 1970 into 2020 is 50 years. Okay? And then our percentage is 0.02. Plug into the formula here. Plug in my numbers. I have P. I'm solving for P. I just plugged this into a calculator. 1.02 raised to the 50, and it gave me all of that. And then I take 120,000 and I just divide all of that by both sides and end up with P on the right. And what's left on the left is the initial amount should have been $44,583.35. A good way to check that would be to plug that amount back here into here and make sure it's somewhere in the ballpark of $120,000. Number 5, Sophie inherited a diamond ring purchased 20 years ago. So our time is 20. Initial amount was $500. Value of the ring has increased 8% a year. So hopefully we see the 8% increase. We don't know what the final amount is after the 20 years. Okay, so it says purchased 20 years ago. Plug in 500, 1.08. This is 1 plus 0.08 is 1.08 raised to the 20. And the ring is now worth $2,330.48. Hopefully pretty straightforward. So now let's do the last one, and I'll kind of work through this one with you. Drug trial determines that it takes 3 hours for a human body to eliminate half of the drug from its system. So a half-life is 3 hours, okay? If 200 milligrams of the drug are administered, so my initial amount is 200. We'll deal with the milligrams in a little bit, okay? Then how much will remain in the bloodstream after 7 hours? And we don't know the initial amount. So if we go back up here, we're going to have A, initial is 200, still a half-life, and now we have 7 divided by 3 is our exponent. So on my calculator now, hopefully you can see that, I'm going to put 200 parentheses 1 over 2, or you could just do 0.5. Then my caret button raised to the 7 over 3. So it should look something like that when you plug it in. Hopefully you guys can see that. And then let's find out. It should have 39.685. So we're going to say 39.69. It should be 39.69, and we're dealing with milligrams. Milligrams left. So let's talk about that for a second. All right, so this is multiple half-lives. So a half-life is 3 hours, right? So that went 3 hours, then 6 hours would be another one. So let's just say we take this half-life, okay? 200, half after 3 hours, you'd have 100. So 100, then after 3 more hours, you'd have 50. So you can kind of see, and then you have 1 more hour left. So you can kind of see that this is it should make sense how it's being worked out. Okay. All right. So that is growth, decay, and half-life. So now let's get to compound interest and continual interest. Again, more formulas. We're dealing with the amount. The initial, final amount is A, initial amount is P, 1. My R is for rate. My N is for the number of times that is compounded. And then my time is time again. So when we start talking about number of times compounded, we're talking about number of times per year. So if we're looking at annual, my N would be 1. If we're looking at semi-annual, that means it would be twice a year or 2. If we're looking at monthly, how many months in a year? Well, there's 12. And then quarterly, just think of quarters. How many quarters are in a year? There are 4. If you split it up, there'd be 3 months, 3 months, 3 months, 3 months. Those are 4 quarters and 12 total months within a year. Okay, so now let's do a couple problems. Jason received $500 in birthday gifts. So his initial amount is $500. He deposits into a savings account earning 2% interest. So 0.02. How much will Jason have when he graduates from college in 4 years if it's compounded? And we're going to deal with different compounds. So this is after 4 years. We don't know the final amount. Okay. Annually would be 1. Quarterly would be 4. Monthly would be 12. And continuous is this formula. We're going to use that E button. A little bit different when we start talking about continuous. So let's talk about what they mean by this compounded. That basically means they're going to calculate it once a year. They leave everything in there and we calculate it once a year. When they're talking about quarterly, they calculate it quarterly. So what happens is when you calculate it quarterly, you put your money in there after 3 months or a quarter of a year, it gets calculated. Then the next time it's calculated, your actual amount is larger because now it's more than 500 because now you're calculating the interest that you had before. With monthly, the same thing, and continuously is almost like continuously. It's like it's compounding continuously. It's like over and over. It's not even daily. Daily would be 365. Continuously is almost continuously. It's just continuous growth. All right, so if we plug in this formula here, we'd have my amount equals 500. 1 plus my rate, which is 0.02 over 1. And my N is 1. And my time is 4. And you simply plug that into a calculator. Again, let's clear this out. I'm going to put 500 parentheses 1 plus. I'm going to do that N over D, 0.02. Now, you don't have to do this because it's over 1, but I'm going to, just so you'll see where I'm getting all these. 1, 4. And boom. So after 1 year compounded, you would have $541.22. I'm rounding that 6 up to a 2. That 6 after the 1 is greater. Cool. Hopefully you saw that. Let's do quarterly. So now I'm going to go 500. 1 plus 0.02. And my N is 4 and 4 and 4 for 4 years. I can literally, if you don't want to type it all, go back up here, pull this down, move over and just re-enter, change my 1s to 4s. Hopefully you guys see that. I know it's a little bit hard to see. And we go there. So quarterly didn't change that much. Now it's $541.54. Not really changing that much. Nothing's really, 2% is really not a lot. So then to do monthly, we can go back up, hit enter, and then go over and change our 4s to 12s. This might be a little bit interesting because we got multiple numbers, but knowing how to work a calculator will be to your benefit here. And we end up with my amount equals 500. 1 plus 0.02 over 12. 12 and 4. And my amount is $541.61. Not that big of a deal either. Again, that 2% is not going to have that much growth. Okay, so now we got a little bit different now because we got to deal with this one for continuous. So now we have A, our initial amount is 500, and we have E, our Euler. Our rate is 0.02, and our time is 4 years. So now we have to use a different button. Okay, so let me clear all this out. So we're going to go 500, and you'll see, where is he at? Where is he at? I'm looking at it from a different angle. Where's my E? There he is, right there, right above the LN. You see that E right there? You have to go second and then E, and there's your E, and then you can put your stuff on top. And continuously, we end up with $541.64. So you'll see there's just some slight differences. Again, 2% is not going to make that much of a change. Hopefully you guys can see that on that, where that E is right there. If you have this kind of calculator, it's kind of pretty repetitive. Once you know how to do it once, you should be fine. So let's do them in a word problem form now and finish this up. Grace deposited $1,000, so our initial amount will be $1,000. 2%. Compounded continuously, so I apologize. It's not what I want to do. My time is 4, but it's compounded continuously. So I'm going to have A equals 1,000, E raised to the 0.02 to the 4. So again, let's clear this out fully. 1,000, second LN, which gives you my E, parentheses, 0.02, and 4. After 4 years, you'll have $1,083.29. Again, not that big of a deal. How much will Grace initially, how much money must Grace initially invest initially, I'm sorry. So I don't know that. To have $20,000 at the end, a little bit different. 18 years at 2% interest. So now we have to write 20,000. P, I don't know. And I'm assuming it's still going to be continuous. Looks to be. And 18 years. So that's what your initial setup should be. Look like that. So we're going to manipulate a little bit this. What you need to understand is this E is a number. Flat out. It's a number. So let's deal with that. Let's just go second and E. And then I go 0.02 and then 18. So E, I have all of this right here, is a number. When I hit that, that's what I end up getting. So I end up with 20,000 equals P, and then all of this is 1.433329415. Please, please, please don't simplify that till you get to the end. Just like the original problem on the other side, we simply divide it. So if you have this calculator, I'm going to show you a quick step. Hit 20,000, divide, second, and then this negative or answer here. So then what it's going to do is 20,000 divided by whatever you did earlier. So you don't have to worry about writing everything down. And you find out that it would be, the initial amount would be $13,953.53. To kind of prove that out, you could then plug that in for P. 13,953.53, second E, 0.02, and 18, and you're looking right at 20 grand. So, yeah, proven. Thank you.